Hello and welcome to Nova. This is one of our STEM videos about oil and oil spills. We hope you enjoy.
Have you ever tried to wash oil off your hands before? If you have, you'll know that only using water won't get rid of the oil. You also need to use washing up liquid or soap. Why is this the case? Today, we're going to show you a quick demonstration that will help us understand this. You can try this yourself at home. All you will need is some water, vegetable oil, a container with a lid, washing up liquid and food colouring. First, we'll fill our container with some water and add in a few drops of food colouring. This will make it easier to see the difference between the oil and the water. Next, the oil is added to the coloured water. Because oil and water don't mix, they form separate layers, and the less dense oil floats on top of the denser water. Now I'll shake it to give it a proper mix. Even when I shake it and leave it to rest, the oil and water will not mix. The oil molecules are only attracted to other oil molecules, and the water molecules are attracted to water molecules, so they won't mix no matter how much you shake the container. So how do we get these two to mix together? For that, we'll use some washing up liquid. So just add in a few drops and shake it up. The washing up liquid contains molecules that are attracted to both the oil and water molecules, allowing the oil and water to mix together. The washing up liquid surrounds the oil droplets, allowing the oil to mix in with the water without actually touching it. As you can see, the layers have gone. We are left with one mixture, and this mixture is called an emulsion. Getting the oil and water to mix is why we use washing up liquid to clean oil off your hands or to clean dirty dishes.
Although the experiment we just showed you uses vegetable oil, the same process applies to other oils, including crude oil. Crude oil is a type of fossil fuel, which means it is a non-renewable and finite resource, meaning that we have a limited supply of it. Other fossil fuels include coal and natural gas. We call these resources fossil fuels because they are made up of the matter of plants and animals that died millions of years ago and were compressed into carbon-rich materials. Because fossil fuels are carbon-rich, it means they can provide us with a lot of energy. However, this also means that they release a lot of CO2, or carbon dioxide, into the atmosphere. Carbon dioxide is one of a collection of gases we call greenhouse gases that are currently causing climate change. Therefore, although we benefit a lot from the use of crude oil, there are environmental impacts associated with it. We use crude oil for numerous things. This includes direct uses such as for fuel in cars, as petrol or diesel, or to make other products such as plastics. We also burn it to generate electricity. This slide shows some of the products associated with crude oil, many of which we use daily. According to the Government Department for Business, Energy and Industrial Strategy, in 2019 we used almost 200 million tonnes of oil equivalent in the UK. Areas where oil is found beneath the Earth's surface are called oil fields. There are a few different ways that we can extract oil from these fields. Traditionally, we would drill for the oil and it would naturally rise to the surface due to the change in pressure. However, as oil fields become more depleted, we have had to move on to new technologies to extract the oil. Another method we now use to extract the oil is fracking. We do this to extract the oil from impermeable rock. This also involves drilling down into the earth to reach the oil, but then water is pumped down to help crack and break up the rock, allowing oil and natural gas to escape the rock and rise to the surface. Although oil is used worldwide, oil fields are found in more areas than others. Additionally, a lot of oil fields are located offshore. They're under the ocean. This makes it very difficult to transport to areas where it can be distilled or used. The four main ways we transport oil are pipelines, trains, ships, or on the road in trucks or lorries. Each of these methods of transportation have positives and negatives associated with them.
So now we know what oil is, what it's used for, and how it's transported. But what happens if something goes wrong? You may recall that oil can be drilled, transported, or used near bodies of water, such as the ocean, shores, lakes, or rivers. If oil is not carefully managed, equipment fails, or an accident happens, an oil spill can take place. Now we are going to test this out for ourselves and try our own oil spill. You will need a few household items, such as water and a container for the water to go in. Oil. Clean up technologies. Here I've got kitchen roll, tissue, cotton pads, cotton buds and tin foil. And you will also need some washing up liquid. Now to move on to the method. Firstly, pour your water into the container of your choice. Next, we're going to add the oil. When you add the oil in, watch how the oil stays separate to the water and they do not mix. Give this a watch in slow motion, you'll be able to notice it more. After we've added the oil, we can see how the oil rests on top of the water. This is because oil is less dense than water, therefore floats to the top. It's really important to clean up the oil spill, as oil contaminates the water and can cause bad environmental impacts, disrupt habitats and ecosystems. We're going to try and clean up this oil using the materials we sourced at the beginning of the video. The first material we're going to try is tissue. You can see that the oil is a bit attracted to the tissue and absorbs up into the material, therefore removing the oil from the water. The kitchen roll seems to be doing similar but on a larger scale and collecting more oil from the area. The kitchen roll collects a lot of oil, however the cotton buds can be used to collect more localised areas of oil spill. The effectiveness of the cotton pad varies depending on where you place it in the water. If it hits water first, it absorbs more water. However, if it hits the oil first, it absorbs the oil. You will notice, although we have tried multiple cleanup technologies, there's still oil in the water. This process was used at the beginning of the video and it's called emulsion. We're going to demonstrate this as we can add the washing up liquid into the water, which allows the oil to mix with the water as the soap molecules surround the oil molecules, allowing the two to mix. You can see now that when we mix the body of water, the oil can distribute evenly across the body. Therefore, there are no large parts of oil in the water anymore. However, sometimes we need to contain the spill. We're going to represent this using a tin foil barrier to contain the additional contaminants. As you can see, the tinfoil barrier has captured any additional contaminants. Although we've performed this experiment in a mixing bowl, this can happen in real life too, using actual cleanup technologies with the same principles as the technologies we've used today. We're now going to go through a case study so you can visualise this in real life.
The largest marine oil spill in history is the Deepwater Horizon oil spill that occurred in 2010. An explosion on the Deepwater Horizon oil rig resulted in approximately 184 million gallons of oil being spilled into the Gulf of Mexico, polluting around 1,100 miles of American coastline. This oil spill occurs due to the failure of several safety systems, lack of understanding, and poor cement quality. Various techniques were used to attempt to contain and clean up this oil spill. For example, dispersants were sprayed onto the oil slick to form an emulsion and speed up the natural breakdown of oil. Around 1.8 million gallons of these chemical dispersants were used. Over 60 skimmers were used to collect oil from the surface as well. Containment booms were also used, which prevented the oil from spilling out any further. This oil was then siphoned off or burned. Unfortunately, burning the oil released many toxic chemicals into the atmosphere. The Deepwater Horizon oil spill had a devastating impact on the environment. The oil polluted the American coastline, resulting in erosion and vegetation being heavily damaged. Even in 2019, the coast has oil concentrations of 10 times higher than that before the spill. The marine wildlife was also affected, as many animals were killed or became extremely sick due to the oil spilling into their natural habitat. This example shows how dangerous oil spills can be and how we must make sure that we can do everything we can to stop these from happening.
Thanks so much for watching. Please remember to like and subscribe so you can stay up to date with our future videos.